Hello, my name is Tate, and today I'm going to demonstrate Gay-Lussac's law. So basically, we're going to measure the pressure and temperature of this bike tire before we do the experiment, and then we're going to drop it in a pool, which is kind of cold, and we're going to measure pressure and temperature after to demonstrate the law. Okay, so we're going to, the temperature right now, you can see there, it says 80 degrees Fahrenheit, and we're going to put the air in it and measure temperature after. So, here, Sean, ready? Go. Okay, so to measure the pressure, you have to use this handy dandy thing. And that says it is, what is that, 16, 17, 18 PSI. So that's our pressure before the experiment, and then we're gonna do the experiment and measure it after. Okay, so we're gonna record the temperature of this pool. It's gonna go down. You can get there, Sean. It's going down. Looks like it's about, oh, here in the shadow, there. Looks like it's about 70 degrees flat. 70 degrees Fahrenheit, yeah. All right, so this is gonna do the experiment. We're gonna just drop the bike tire right here. We're gonna set a weight on it, and we're gonna measure temperature and pressure in a few hours. Okay. There we go. Nice. Okay, so we let it sit in there for an hour. We're gonna pull out the tire and measure the pressure right here. See if it's gone down at all. It actually did. It's about 16 PSI, so that's 2 pounds per square inch less.
Alright, so this is for the Gay-Lussac's law. So temperature 1 was 80 degrees Fahrenheit. Temperature 2 was 70 degrees. What am I doing? Degrees Fahrenheit. That's in Fahrenheit. Pressure 1 was 18 ATM? Not ATM. PSI? PSI, that's right. Okay, 18 PSI. And then P2 is what we're trying to find, so that's X. So to convert this to Celsius, you subtract it by 32, which in this case would equal 48, and in this case would equal 38. Then multiply it by 5, and you get 240, and multiply by 5 here, and you get 190, and then you gotta divide both of these by 9. So let me just whip out a calculator real quick. So 240 divided by 9 equals 26.6667, which I'm gonna go ahead and round up to 26.7. And then 190 divided by 9, I believe is gonna be like 21, just off the top of my head. 21.11. So 21.1111, which I'm gonna go ahead and convert to just 21.1. So that's the degrees in Celsius. Then you're going to do 273 because you're converting it to Kelvin. So 273 plus the degrees in Celsius. So 273 plus 26.7. So 273 plus 26.7. And you get 299.7. And here you're 273 plus 21.1. So 273 plus 21.1, 294.1. So then you're going to use the Gay-Lussac's law formula, which is P1 over T1 equals P2 over T2. So we're going to go ahead and plug this in. So it's 18 PSI over 299.7 Kelvin is equal to X, because that's what we're solving for, which is P2, over 294.1 Kelvin. So now if we do the math here, 18 PSI times 294.1 Kelvin equals 5,293.8, which is equal to 299.7 X. So then you're going to divide this number by 299.7. So go ahead and just write it out here. Divide both sides by 299.7. And X equals 17. I'm going to go ahead and round this up to 17.7 PSI. So that is our theoretical yield. So theoretical yield. All right.
Okay, so we found our theoretical yield was 17.7 psi. To find the error, we have to subtract 17.7 from our actual yield, which was 15 psi. And that should be 2.7. So that's our error. And divide that by 17.7. So we're going to divide that. 2.7 divided by 17.7. We get 0.153. So multiply that times 100 equals 15.3% error. All right. Go.
All right, so this is Sean here. So we're doing an experiment with Charles' law. So basically we're going to measure the temperature and the volume of this balloon before we heat it up and after we heat it up. And yeah. All right, so we cut the string to get it perfectly around the balloon to find the circumference. So this is it. Each end is touching the other end. So if we take this out, we'll measure this in inches, correct?
Mm-hmm.
So we'll get this in inches, and it's going to be from one end to the other. It's still going to be about a foot.
About, what's that, 11.5?
A little more, about 11.6, we'll say.
Yeah.
About 11.6. So
Right.
that can be the circumference before being put in the boiling water.
Okay, 1.
All right, so we're going to put the thermometer in the water here to get the exact temperature in degrees Fahrenheit. And as you can see, it's about 70 degrees. That's like exactly 70.
Mm-hmm.
So that's it before being boiled. All right, so now I'm going to measure the temperature of the boiling water. Actually, I'm not, because I don't know. Okay. Oh, look, it's getting all smogged. Can't even, there you go.
Right.
Wow,
It's probably about 180. Almost 180 at least.
170, so we'll
Yeah.
just hold it.
Okay, so you put the balloon in. There, yeah.
So I'm just
we're
gonna.
leaving a crack
there's
there,
a crack.
yeah.
Crack has been
Okay.
left.
So we're gonna leave it there for a while and see if it expands.
It's expanding. It's expanding. Alright, balloon's out. I'm gonna hurry up and measure it before it decreases in size.
Yeah, just put your finger where it meets.
It's right there.
Here
So
we go.
I have my finger on the exact measurement of where it meets. And it's gonna be
It's definitely bigger. Wow.
about.
I don't know if you can see that.
It's on
So
it's
12
gonna-
plus
about
6.
17 inches.
So, yeah, 17 inches. All right.
It's about 16.75.
Okay. Okay, so this is for our balloon experiment for Charles's law. So we're gonna have our formula, if you remember, is V1, T1, and V2, and T2. So we are solving for X, or for V2. V1, if you remember, it was 11.6 inches. Temperature 1, it was, what was it? I believe it was 70 degrees Fahrenheit. And then temperature 2 was 170 degrees Fahrenheit. Okay, so we realized it was actually 78 for temperature 1 before we did the experiment. So to solve, we remember the formula is V1 over T1 equals V2 over T2. So if we plug in our numbers, we get 11.6 over, we have to convert this to Kelvin, so I haven't done that yet. And X is V2, and then we have to convert these other ones to temperature. So 78, remember the formula is you have to subtract 32, and to get that, it's 46. And then multiply by 5. So let's see, let's do that. 46 times 5 equals 230. And then divide that by 9. And that is 25.56, let's say. So then we have to add that to 273. Plus 273. And that's 298.56 Kelvin. All right, so that's our temperature 1, 298.56 K. Okay, now 170 you have to convert. So 170 minus 32 equals, what is that? It's 138. And then apply that times 5. 138 times 5. Get 690 divided by 9. 76.67 plus 273. And that is 349.67 Kelvin. Okay, 67 Kelvin. Okay, so now to solve, we have to multiply that times 11.6. So 349.67 times 11.6. So 349.67 times 11.6 equals 4,056.17. And that equals 298.56x. So divide that by 298.56, and we get 13.59, let's say. So that is our theoretical circumference of the balloon.
All right, so the theoretical yield is 13.59. And then you're going to subtract that by the actual yield, which was 16.75. So doing some math. And at the top of my head, it should be like 3.16, I want to say. It is negative 3.16. So using absolute value, the absolute value of that equals 3.16. And then you divide it by 13.59. So 3.16 divided by 13.59. You get 0.23, about 0.232, no, that rounds up to 3, so we'll say this, times 100, so 0.233 times 100, 23.3% error yielding. Bang. Error.
Okay, so we're going to do the experiment. We're going to measure pressure and temperature after in a couple hours once the temperature cools it down. So I'm going to set a weight on it, leave it in the pool.
So I'll cut it here. So once the two ends touch, little touch tips there. You're gonna. All right, so I'm now gonna put the balloon into the. Shit. Okay. So now I'm gonna record the temperature of the boiling water. So as you can come see here, I'm gonna try not to kill myself getting burnt. Ow, this is really hot. Holy crap, my hands are burning. I can't. So we're gonna go ahead and put the balloon in, and it should increase a bit here. So now it's trapped.
Wait, leave a crack.
We'll leave a crack so it doesn't explode. Okay.
Or not.
No.